Okay, this is a very nice problem. It says that throughout this problem, consider the region R that is bounded by the curve y equals x negative 2 all to the power 2 and the line y equals 4 negative x. So the region which we are taking into consideration is the region bounded by this curve and this line. Now what the question says is that it says A, plot the region R and label the point where the curves intersect. Show all the coordinates of this point on the sketch. Now the next question says write an integral that describes the area of the region. Specify which area element you are using, whether you're using the vertical slice or you're using the horizontal slice. And the last question says evaluate the integral that you obtained or the integral derived from part B. So as usual, the very first thing you want to do is you want to draw your x and your y axis. So that's what I already have, that has been pre-sketched here. So let me go ahead and label this. So this is going to be my y axis and this is going to be my x axis. Now I go back to the problem statement. It tells me that the region which we are taking into consideration is bounded by y equals x negative 2 all squared and the line y equals 4 negative x. So I'm going to sketch y equals x negative 2 all squared first. Now when you sketch that, apparently this graph y equals x negative 2 squared is going to intersect the y-axis at this point, at the point 4, and it's going to touch the x-axis at the point 2. So at this point here, let's call this point 2. So the kind of curve you're expecting is something like this. So nothing fancy, just for illustration. Something like this. So this is just y equals x squared shifted to the right because of the negative 2. So anyway, this is our curve. This is our curve here. So this is the graph for y equals x negative 2 all squared. Now we have the graph for y equals x negative 2 all squared. Then the next thing is the line y equals 4 negative x. The line y equals 4 negative x. Also, to plot the line y equals 4 negative x, it intersects the y axis at the point at this point here, at the point 4, and it intersects the x axis also at the point 4 here. So let's assume this is point 4 here, because you can see it has a slope of negative 1. So again, nothing fancy, just to draw. My line is not going to be straight this time around, but so that is, we get a picture of what we're talking about here. So this is my line here. This is a straight line, and this is line y equals 4 negative x. Now what the question says is that the region which we are taking into consideration is bounded by the curve y and the line y equals 4 negative x. So this is the region here that's been bounded, the region that we have inner here, the inner region here. So I'm just going to thicken that just for illustrative purpose. So this is the region. This is the region R. Yep. Now we have this. Now what the question says, so the very first question, what it says is, it says plot the region R. So we have done that. So this is my region, R. It says label the point where the curves intersect. So I'm going to start by labeling the curve, the point where they intersect. So I'm going to call the first point, let me call this so they intersect at this point. I'm going to call this P1, and they also intersect at this point. I'm going to call this point P2. So I've labeled the point where it intersects. Then show all the coordinates of the point on the sketch. So so now to find so these are my points. So the next thing is I want to find the coordinates of this point P1 and point P2. So let's go ahead and find the point of intersection. Now that's the very first now I want to do. So let me just write that down here. The point of intersection. So let's call that A. The point of intersection Now at the point of intersection, that is the point where the graph y equals x negative 2 all squared, that's the point where they equal each other. That's at this point and at this point they are equal to each other. So I'm just going to set them equal to each other. So you have x negative 2 all squared equals 4 negative x. So what I do next is I'm going to solve for x. That's what I'm going to do. Now when you expand x negative to all squared, you have x squared negative 4x plus 4 equals 4 negative x. Now to solve for x, I'm going to bring 4 and negative x to the other side. So we're going to have x squared negative 4x plus 4 negative 4 plus x equals 0. So if you solve for that, you have x squared. So negative 4x plus x is going to give me negative 3x, and then 4 negative 4, they cancel each other, and then you have x into x negative 3 equals 0. So this gives me x equals 0, and it gives me x equals 3. So now you recall we have two functions. So this is the first, this is the second. So we know that y equals 4 negative x. So what we have here is two corresponding values for x. So when x equals 0, what is the value for y? Now y is just going to be 4 minus 0, and that is 4. So this is the first one. So the first coordinate is just going to be, when x is 0, my y is 4. And then the next one, it says when x equals 3, what is my y? My y is just going to be 4 negative. So in place of x, I'm going to put 3 here, and then you have 1. So this is basically what we have as our coordinates. So our coordinate is going to be 3, and then this is just going to be 1. So I can go ahead, 0, 4, and 3, 1. So this is apparently going to be 0, 4. So this is 0, 4, and then this is going to be 3, 1. Because you can see it corresponds to the point we have here. So this is just going to be 3, 1. So now we are done with the first question. Now the next one here says write an integral that describes the area of the region and specify which area element you're going to be using. Well, to do this kind of problem, you could either use horizontal slice. When I mean horizontal slice, I actually mean you're taking slices, horizontal slices like this, and if I say vertical slice, you're using vertical slice. So anyway, for this problem, we're going to be using vertical slice. So I'm just going to pick this point here. So I'm going to be using a vertical slice. So again, the technique we're going to be using here is you start by slicing. When you slice, you sum. When you finish summing, then you take the definite integral. Now, so it says which am I using? So I'm going to be using vertical. So I'm using vertical. So that's what I'm going to be using. So what I want to do is we want to find the area of this slice here. So when we bring this slice out, so what we have is this is our slice. I'm going to call this delta x, that is the change in the length here. I'm going to call this delta x. Now the bone of contention is how do I find the length of this slice? Well, what you observe is that for this curve from here to here, that is the height of this curve here, is actually the value of the function. This is the function y equals 4 negative x. So the height is the function itself. So this is 4 negative x, and then the curve that we have here, that's the curve itself. So this curve is from here to here. Now that is x negative 2 all squared. So what we want to do is we want to find the distance from here to here. That is the remaining distance. Now how do you find the remaining distance? It's actually going to be the subtraction of x negative 2 all squared from 4 negative x to be able to find this distance here. So in other words, the length that's from here to here is just going to be 4 negative x minus x negative 2 all squared. So this is my height, and then the width is delta x. So this is the rectangle. So since this is the rectangle, to find the area, so which I'm going to call the change in A, is just length times width. That is the length, which is 4 negative x minus x negative 2 all squared. So this whole quantity here times the breadth. Now this is my delta A. So the next is when you expand this. So when we expand this, we're going to have 3x minus x squared multiplied by delta x. Now this is what I have for my delta A. So again, you recall, the first is we've gotten the area of the slice, then the next is we sum. We sum the whole slices. So that is the total area. So the total area is just going to be the sum of all what we have here, which is 3x negative x squared multiplied by delta x. But then the thing is, we want to find the exact value. Now to find the exact value, so that is the exact area. The exact area is actually the limit as delta x tends to 0 of this whole thing here. That's 3x negative x squared multiplied by delta x. Now whenever you take the limits, two things change. So this changes and then also this changes. So in other words, what we're going to have as the exact area, so this summation here changes to the big S, which is the sum, and then you have your 3x negative x all squared, then your delta x also changes to the x. So we need to know the limits of integration. So as you can see, our x runs from this point that we have here to this point here. You can see it runs from, so we're going to be having this sum going like this from this point here up to this point here, so up to this point here. So how do I know this point? Well, you observe that this is our x value. Our x equals 3 for the point of intersection. So that means this point here is 3, and then this point here is actually the origin. As you can see here, the point of intersection there is the x coordinate is 0, so this is going to be 0. So that tells me that my limit of integration is from 0 to 3. That's from 0 to 3. So this is just going to give me the integral of this, which is actually 9 divided by 2 square units. So this is basically the solution of the problem. I've actually combined the two questions here. It says write an integral that describes the area of the region and specify which area elements you're using. So we are using the vertical slice, and the integral that represents the area. This is the integral that represents the area here. That's what you have here, and it says evaluate it. So this is the evaluation, 9 over 2 square units. So that's basically how the problem is solved. So should you have any problem, feel free to drop your questions in the comment box below.